Okay, here's part 2 of our periodic table notes. This is a screencast that will help you with the quiz on the periodic trends. So here's the different periodic trends, and these are the patterns that reoccur on the periodic table. Okay, it's a very powerful aspect of the periodic table is that you can use it to predict these certain trends, which these trends relate to how elements react with each other. So the first one we're going to talk about is atomic radius. The atomic radius is the size of the atom. It is officially defined as the distance between two half the distance between two like bonded nuclei of the same element. So, like for example, if you had hydrogen, you had H2, right? The distance between the H2 atoms, half of that is the size of the atom, right? So it decreases as you move left to right across a row, and this illustration here tells you why. Okay, so if you're looking at the first row on your periodic table and you have hydrogen and helium, hydrogen has one electron and one proton. Okay, and because Coulomb's law says that opposite charges attract and like charges repel, the electron that is negative is attracted to that proton in the nucleus, right? And so there's a certain amount of attraction there, which I've represented by this red arrow. Okay, and helium then has two protons in the nucleus, and it has two electrons, but those two electrons are in the same energy level, right? They're in the same circle that's outside of the nucleus. And so they are both drawn towards those two protons, right? Each electron feels the charge of two protons in helium as opposed to the one proton in hydrogen. Okay, and so the electrons are pulled closer to the nucleus. That decreases the size of the atom as you move across a row. And so it increases as you move down a column because when you add more electrons as you go down the periodic table, it adds layers of electrons or different energy levels of electrons. And so I've illustrated that here with hydrogen and lithium. So in hydrogen you have one layer of electrons, but in lithium you have two layers. And so lithium is clearly larger than hydrogen is because that electron is in the outermost energy level. It's farther away from the nucleus because the inner energy level was filled. And because the inner energy level was filled, that electron had to go into the next energy level. Okay, so atomic radius increases as you move down because the atoms become larger, and they become larger because you're adding more energy levels. And so this is the general trend that you see as you go along the periodic table. So as you go to the right, from left to right, the atomic size or the atomic radius decreases because those electrons that are added to the same energy level, but there's more protons in the nucleus as you go from left to right. And so because there's more protons in the nucleus, those protons are positively charged, and those electrons, each of those electrons feels more pull towards the nucleus. As you go down the periodic table, the atomic size increases because you're adding more layers. Each row on the periodic table is another layer of electrons that's added to those atoms. And this is actual data on the size of the atoms. So you can see hydrogen has a size of 37. That's the size of the hydrogen atom, the radius of the hydrogen atom in, I believe, picometers. And then if you go down, you have lithium as 152, which is larger than hydrogen, right? And then sodium, larger than lithium, at 186. And as you go across a row, you'll see that the size decreases, right? Because you're adding more of the protons to the nucleus, and those electrons on the outside are more attracted to it. The next trend we're going to talk about is ionization energy. Ionization energy is the energy needed to remove an electron from an atom, which increases as you move across the periodic table because those electrons being pulled closer to the nucleus, they're more attracted to the nucleus, and so you need more energy to add to that atom to remove those electrons. Okay? It decreases as you move down because those electrons are farther away from the nucleus, so it takes less energy to take them away. So ionization energy is directly opposite of atomic radius because of what it is and what it means, okay? And so you can remember the trend. It's easy to remember the trend, but if you don't want to remember the trend, you can just understand how it works. And everything that happens as far as the periodic table is concerned happens because of protons and electrons being attracted to each other. And so as you see, here's another little illustration of the trend, right? Ionization energy increases as you go to the right on the periodic table, and ionization energy decreases as you go down. Now, electronegativity is similar to ionization energy, but it's different. And electronegativity is an atom's desire to attract electrons to itself. And so when atoms bond together to form compounds, okay, the ones that are more electronegative will have the electrons closer to them and will have a negative charge, whereas the more electropositive or the less electronegative atom will have less electron density close to it, and so it'll be, in effect, more positively charged. Okay, this is how you have positive and negative ions, because the negative ions are the ones that stole the electrons away from the positively charged atoms, and the positively charged atoms are positive because their electrons were stolen away. Okay, and so electronegativity increases as you move across the periodic table from left to right, with the exception of the noble gases. Noble gases have no electronegativity because they have no desire to bond, so they don't attract electrons to themselves because they don't bond. Okay, but as a general rule, as you go to the right on the periodic table, the electronegativity increases, just like ionization energy. And it decreases as you move down, just like ionization energy. Because, well, as you get more layers of electrons, those atoms are less attracted to more electrons because that effective nuclear charge is effectively decreased by the shielding of those outermost electrons from the nuclear charge. And so here's a beautiful illustration of electronegativity. The highest electronegativity on the periodic table is fluorine. Fluorine has the highest desire for a shared pair of electrons. So it has the largest attractive force for electrons. And the lowest is down here with cesium. This lists francium as the lowest. Francium is radioactive. It doesn't attract electrons because it doesn't really have a very stable half-life. So cesium is in effect effectively the lowest electronegativity. And so I thought we'd end this with the periodic table song. This is a periodic table song that goes over all of the elements in the periodic table in order, and it's beautiful. It's done by the ASAP Science guys, and I really love them, so I hope you'll love it too. So hopefully you're ready to take the quiz. If you want, you can also have the PowerPoint next to you, right? Pull that up while you're taking the quiz. And if you don't do get a perfect score the first time, just take it again.